Thank you very much. So, then welcome to the Cloud Controller Performance Tuning session. So, my name is Jochen, working at SAP. And just to give you some context what we are doing. So, in my team, we take the open source Cloud Foundry CF deployment, validate and integrate this into our product, and then sell this as SAP Business Technology Platform Cloud Foundry environment. It's now 7 years that we adopted Cloud Foundry, and a lot has happened since then. And as of now, we are operating some of the world's largest foundations with thousands of orgs, apps, spaces. And so you can imagine that if there are performance problems with the cloud controller, it is usually us who find them first, or in the worst case, our customers find them. And that's why we have invested a lot in cloud controller performance, tuning, and monitoring. And I want to show you what we have done. First, a little more data about what we are doing. So this is all our data centers where we are operating Cloud Foundry. So we are running on AWS, Azure, GCP, and Alibaba, as you can see, almost all around the world. Then some adoption numbers. In total, we are running 317 terabytes of Diego capacity. We have around 2,168 active users. So users is not a single person. These are organizations or accounts. This is a bit generalized, the numbers. And we have around 17,000 active orgs. So this is our biggest foundation, our Cloud Foundry masterpiece, one of our what we call landscapes. So it has in total 118 terabytes of Diego capacity. We have 60 Go routers, 162 API nodes, and as you can see, 400,000 users, 462 Diego cells. So this is one of our biggest challenge to keep this important landscape up and running. So what have we done now to improve performance? We have made over 100 pull requests for the cloud controller in the last 2 years. Mainly for performance and stability issues. And here I will show you a few notable examples. So this one here, improved performance of service plan offering list fetching, is a result of an outage. So on the biggest landscape, we had a problem that there were a lot of requests to the service plan endpoint, and the database could not keep up with the load. And then we analyzed the Postgres execution plans, we had a Postgres consultant, and then eventually find out that the query is not optimally designed for Postgres. And here we then redesigned the query to use union statements instead of multiple OR statements. And this turned out to be significantly faster, and then we did not have any further outages in this area anymore. Here's another one. As you know, we're still transitioning from Cloud Foundry API version 2 to version 3, and to encourage the users who are still using V2, we have implemented a rate limiter. And the idea is that we cut the rate limit for V2 calls in half every sprint, so that calls get slower and slower, and by this motivating everyone to use the V3 API. So, and here another one. This is from our Engineer Better colleagues. Here again, we had a very slow endpoint. As you know, in Cloud Foundry, you have domains which may be related to organizations, and if you're operating on thousands of organizations, the query may get very slow. And it turned out that we had a query with an in statement with a very, very long array, and then this array had to be sent to the database, and this was very, very slow. And Andy successfully refactored the query so that it is much more performant by using subqueries. This was a very complex change, but it was well worth it. Good, what else do we do? This is a very interesting proof of concept, and I must say it was also fun to work on that one. We have evaluated if it is possible to re-implement the cloud controller on Go and what it would take to do so. So the motivation is that the current cloud controller has some performance and scalability limitations. Most notably, there is a limit for scaling out, and this is the number of database connections. So on AWS, we are already running on the biggest RDS database that you can buy, and it offers 5,000 connections, and then one cloud controller node needs so and so many connections, and this is then the limit of the number of API nodes you can have, and then you can't scale out anymore. And that's why we tried to, there are other limitations. For example, the Ruby does not make perfect use of the available CPU resources and so on. And many other Cloud Foundry components have already been migrated to Go for similar reasons. And we wanted to check what does it take to move the cloud controller to Go. There's a large discussion in Google Doc, and with all design decisions, and this is what we then came up with. This is the technology stack. So as a web framework, we use LabStack Echo. Then we use SQL Boiler to generate the Go coding from the existing database schema, Prometheus to expose the metrics, Zap for logging, and Mage as a build tool. A few more other tools are also used, but these are the most important ones. Now, when you have the Go controller partially implemented, you need to create a BOSH release, and then for testing the whole setup, we deploy the Go Cloud Controller and the classic Cloud Controller side by side, and use the Cloud Foundry Go router to route the newly implemented endpoints to the Go Cloud Controller, and the rest goes to the old Cloud Controller as before. So that's how you can deploy both side by side, even when the Go Cloud Controller is not finished. You need one additional component, the HA proxy, so that you can do a fine granular distinctions on the HTTP method that is used. So currently we have only implemented some get endpoints, and put post delete is then routed to the old cloud controller. This would also be the approach for a productive rollout. So a big bang approach where at some point in time you replace the old cloud controller with the new one will likely not work. Instead, you do this side-by-side approach where you deploy both, and as more and more endpoints are implemented in Go, you add them to the, you register them in the Go router so that more and more requests are routed to the new cloud controller. Now, how does it perform? We have done some load tests with Vegeta as HTTP load testing tool. And we have implemented only the simplest endpoints for now. That is v3 build packs or v3 security groups. v2 is, of course, not implemented. Yeah, and then for Ruby, we've found that the build packs returns around, can handle around 30 requests, and in Go, it's 550 requests. And for security groups, this is already a bit more complicated because we have multiple SQL joins. Here in Ruby, we had 40 requests per second, and the Go implementation could handle around 750 requests. So this also already looks quite promising. And this is the current implementation state. So we have implemented only v3 info, v3 security groups, and build packs. If you're interested, the sources are on github.com Cloud Foundry in the Go CF API repository. That's how we are naming this project at the moment. And you can also find all architectural decision records in this document here. Now, how do we go forward from this point? Of course, a full re-implementation could take 2 to 3 years, depending on many factors, how much resources you have. So this is it's rather unlikely that we follow this approach. We first want to use all possible optimizations for the classic cloud controller. That is, we will continue to optimize queries. We will wait for the Puma migration and Ruby 3.1. Also, we will try to enforce the deprecation of the v2, because for several v2 calls, the response time can be up to 3 times longer as for a corresponding v3 call. So, but we keep the Go implementation as a kind of reference for performance and load measurements. So, if the classic cloud controller does not meet our performance and scalability requirements for very large foundations, and we cannot optimize any further, then we would be forced to continue with the Go re-implementation. So that's the statement we can make as of today. Okay. Another project were the systematic CF performance tests. So our goal was that we find slow endpoints in the cloud controller before our customers do. And we also wanted to have a way to analyze performance impact changes to the cloud controller code base. And we wanted to find queries that do, or we wanted to ensure that queries do not scale exponentially with the database size. So that's why we wanted to create a systematic approach for CF performance tests. We have implemented the tests both for the Ruby Cloud Controller and for the Go proof of concept. And we also have by now implemented everything for Postgres and also for MySQL database. So the technical setup. First, of course, we need a plain Cloud Foundry foundation. We do this with Bosch bootloader and plain CF deployment. Then we need to seed the database with test data. For that, so test data means thousands of orgs, spaces, security groups, whatever you want to test. We've checked multiple approaches for seeding the database, and it turned out that the only efficient way to do this is with stored procedures. Where you have a function like create number of orgs and then let the database do the workload. Sending single requests is all too slow. So this with stored procedures, this is the fastest way, but of course you have to implement it 2 times, 1 time for Postgres and 1 time for MySQL. And this is also the most cumbersome part because the syntax for stored procedures is not always very nice if you have many nested for loops. Good. Once the database is seeded, then we run tests with gmeasure. So that's kind of Ginkgo tests, which then record how long a test took or ran multiple samples and report average numbers and all that stuff. And then you get a large JSON with response times. And from that, you can create charts with Python's matplotlib. So putting it all together, we created this concourse pipeline, which does all the steps. So first we set up the infrastructure with Bubble. We deploy a plain CF. We run the tests against Postgres and MySQL, generate the charts, and then tear down the test landscape. And a similar pipeline we have for the Go Cloud Controller. This approach also supports backfilling across multiple CF deployment versions. That is, we can have kind of history for each new CF deployment release and check if there was a regression or an improvement. So, and here's one example. Here we check the response time of the v3 domains endpoint. One time as admin, one time as regular user. There are differences. Admin sees everything. Regular user may only see a subset. And then we also test this with small and large page sizes and so on. And here you can see that the query optimization in CAPI release 1.113 shows a significant improvement. We already have a lot of other charts for other endpoints. They need to be recreated one or two more times because we have migrated to Ginkgo v2. So it's all a bit work in progress. I picked the best looking chart for this presentation, but we will rerun everything so that we have comparable results. If you're interested, everything is on GitHub.com. So the tests and the database setup is in the CF performance tests repository, and the automation pipelines and I think also the test results are in the CF performance tests pipeline repository. Pipeline is currently still hosted on the Bosch CI concourse, but it is planned to move everything to the application runtime interfaces working group concourse. Good. So then last topic, I think already, Cloud Foundry load tests. So load tests, here we want to determine the maximum throughput one cloud controller can handle. Yeah, so for performance tests, we want to measure how long does it take for one request to be processed, and here we want to determine the maximum. And again, we want to compare the Ruby implementation with the Go proof of concept. And the technical setup is in total quite similar to the performance tests. But here again, we use Vegeta for HTTP load testing. And yeah, well, this is what it then looks like when Vegeta starts running. So for example, here you do a load test of the v3 security groups endpoint, and then it starts with an attack rate of 80, and then it increases this rate until it receives too many errors, and then you know where the boundary is, how much load a certain endpoint can handle. And again, with Matplotlib, you can create these nice charts. So here you again see that the maximum throughput of the Go CF API is significantly higher than of the current implementation. This is all a bit work in, it's still work in progress. So we have implemented or tested only very few endpoints. We need to rerun this a few times to get stable results. So that's why, unfortunately, the load tests are not yet available on GitHub.com. These are stored SAP internally. Performance tests are available, but we will also try to complete the test charts for every endpoint that is interesting for us. And we will also in future include the Golang POC for reference. Yeah, it's SAP internal, and also when this is ready, we will move everything to the application runtime interfaces concourse. So That is all. If you want to know more, then now is time for question answers, or you contact one of us here. So Stefan Merker is the product owner at SAP for most of the topics I just showed, and yeah, Behan is here in the audience. Yeah, and now, any questions? Cloud controller. How many cores do we test on the cloud controller was the question. So for performance tests, we use plain CF deployment with the default VM sizes, yeah, without any modifications. For load tests, I'm not 100% sure, but it should also be the default setting, yeah, but only one cloud controller. Yeah.
Have you done anything to test the regression from V2 to V3 for performance? Like setting up, retrieving the very same information with V2 versus what it will look like with V3. It mentioned you did something with that, but I don't see anything actively being done to compare and contrast those.
Yes, in the performance test projects, ideally we would test all endpoints, V2 and V3. Yeah, we have done this partially. We have tested some interesting V2 and the corresponding V3, but of course not yet all. So yes, this is the goal of the performance tests project, to have charts for all endpoints. And then of course you can compare V2 to V3, yes.